You ever wonder why you lift weights and eat a lot of protein to promote muscle growth? What's the underlying factor? Why does eating more protein and doing progressive resistance exercise, the overload system, in other words, weight training, why does it make your muscles bigger? Well, one of the underlying cornerstones of muscular growth or muscular hypertrophy, as it's known in science, is muscle protein synthesis. Now, what controls muscle protein synthesis? Well, amino acids, especially the essential amino acids, the 9 essential amino acids, those are the main constituents that are involved in muscle protein synthesis. But there is a kind of a director involved in the body that directs the amino acids and basically directs the anabolic pathways that result in increased muscle hypertrophy or growth. Now, this particular substance has actually two names. One of them, the original name was called the mammalian target of rapamycin. More recently, it's been called, for some reason, don't ask me why, now they call it the mechanistic target of rapamycin, but in most cases, it's just referred to as mTOR. Now, mTOR is a very important substance. It's a primary growth substance. mTOR is an example of what they call in science, this is a kind of obscure term, but scientists are familiar with it. It's called antagonistic pleiotropy. Antagonistic pleiotropy refers to something that's good for you when you're young, but when you get older, it kind of turns against you. I'll give you a quick example of that. Insulin-like growth factor 1. Insulin-like growth factor 1, which is a product of growth hormone produced in the liver. When growth hormone is secreted by the pituitary gland, when it gets to the liver, it stimulates the production and release of insulin-like growth factor 1. There's another form of insulin-like growth factor 1, or IGF-1, that's produced in muscle. But the point being that insulin-like growth factor 1 is very important. It's involved in growth. However, when you get older, it's also involved in accelerating the aging process. And some scientists believe that it's a potent stimulant of cancer and tumor formation. So in other words, it helps you when you're young to grow and mature, but when you get older, it more or less turns against you. There's another gene called the P50. This is another example, the P53 gene. Now, with the P53 gene is a tumor suppressant gene. Elephants very rarely get cancer because they make a ton of this P53 stuff. It's kind of a protein, and it seems to prevent the development of tumors and cancer, and that's why elephants very rarely get cancer. Now, humans have this same gene or protein. When you're younger, it serves you well because it helps, again, to prevent the formation of tumors. In other words, it protects you against getting cancer. However, as you get older, the P53 also tends to accelerate the aging process. So, this is, again, two examples of antagonistic pleiotropy. But another example is mTOR itself. mTOR, as I said, it's involved in cellular growth. It's needed for, it actually directs the course of protein synthesis. Obviously, it's extremely important for building muscle. When you take amino acids, as I said, you stimulate mTOR because one in particular, the branched chain amino acid leucine, it's the most potent stimulator of all the amino acids in stimulating mTOR activity, and it does that by inhibiting another substance that inhibits mTOR. And so basically, leucine kind of opens up the door for mTOR to work. Now, mTOR, as I say, it directs amino acids. It controls what they call downstream anabolic factors that increase protein synthesis throughout the body. Now, that sounds good, right? Now, but what happens is when you get older, in most people, mTOR tends to be a little bit too active. And they've shown in studies that overactivity of mTOR, especially when you pass the age of 40, it seems to have a relationship to developing just about every degenerative disease you can think of. Cardiovascular disease, Alzheimer's disease. It's involved in depression. like I say, just about, and worst of all, mTOR they think speeds aging considerably. In animal studies, when they give a substance, and there's a one main substance, which I'll get to in a minute, that inhibits mTOR, the animals live longer. In fact, they think that calorie restriction involves reducing the daily calorie intake an average of 30 to 35%. And they've shown in dozens of animal species, ranging from rats to dogs, that if you put them on a calorie restricted diet, they live longer. Now, the thing is, why calorie restriction extends life, there's a lot of possibilities, theories of why it works. One of them is that it stimulates a process called autophagy, which is kind of an internal house cleaning where your body gets rid of old cells that can cause inflammation and serious health problems. Another is that calorie restriction increases cell-protecting proteins called sirtuins. And still another reason, and this is accepted by a lot of longevity researchers, they think that calorie restriction helps to extend life by considerably blocking the effects of mTOR. It lowers mTOR. So basically, mTOR stimulates the process of aging. So taking things that modify mTOR theoretically will slow aging. Now they've done, again, there's an ongoing study involving dogs, older dogs. They've given them a drug. This drug is called Rapamycin. I'll explain this in a minute. But when they give the dogs Rapamycin, thus far, the older dogs have lived an average of 2 to 3 years longer than normal. A lot of scientists believe that, and a lot of people, especially the longevity hackers, as they call themselves, will believe that taking Rapamycin will also extend human life. There's these studies of humans. I believe there's been 1 or 2 studies of older people where they've given them certain doses of Rapamycin. It does seem to improve their health, but the evidence is not really solid. Let me put it this way, that Rapamycin will indeed extend the lifespan. It's right now totally theoretical. Now, what is Rapamycin? We'll talk about mTOR in a second, but Rapamycin is a drug. In 1965, scientists were studying the soil on Easter Island. Easter Island's that famous island which has the weird statues, these big giant heads on the island. It's in the middle. It's kind of in the middle of the Pacific Ocean, little island. But in 1965, scientists were on the island, and they were taking samples of the soil on Eastern Island. Now, they found a particular bacteria in the soil that produced a substance. When tested, it was shown to have potent antifungal activity. In other words, it works against fungus. So the scientists envisioned it as an antifungal drug, and they named it Rapamycin. Mycin kind of refers to it as a kind of an antibiotic effect. The Rapa stands for Rapa Nui. Rapa Nui is the native name for Eastern Island. That's the real name of Eastern Island. So they called the drug Rapamycin. A couple of years later, they discovered that Rapamycin was a very potent immunosuppressant. In other words, it suppresses immune response. Now, normally you don't want to suppress immune response because the immune system protects you against diseases, viruses, bacterial diseases, and even cancer, even tumor formation. But in certain instances, you do want to suppress the immune system. For example, if you get a kidney transplant, the body will try and destroy the transplanted kidney because it looks at it, it's identified as a foreign protein. So in order for the kidney transplant to take hold, you have to kind of suppress the immune system enough not to kill you, but to allow the body to accept the kidney. And the drug of choice for many years to do that has been Rapamycin. Now, over the years, as they discovered the effects of mTOR, now Rapamycin, now remember, what mTOR stands for is mechanistic or mammalian target of rapamycin. In other words, what that means is rapamycin affects mTOR, basically turns it off. And as the research emerged, or let's say evolved around mTOR, and when they realized how excessive amounts of mTOR cause a number of, are associated with in animal studies, just about every degenerative disease you could think of. I'm talking about excessive amounts of mTOR. They decided to repackage, well, a lot of people did. This isn't, I mean, it hasn't been officially declared as such, but rapamycin was kind of repackaged as the anti-longevity drug. In other words, there's a lot of people that will tell you that the only drug that truly will extend the lifespan is rapamycin, and the rapamycin works by inhibiting mTOR, right? So the thing is, now you might say, now basically this raises a couple of questions. First of all, as I said, there's some initial studies with dogs and other animals showing that rapamycin does efficiently inhibit mTOR, and again, if you inhibit mTOR, theoretically, you could prevent a lot of these age-related diseases and possibly slow down the aging process. But an important point to remember here is that most of this is theoretical now. In other words, the mechanism makes sense, but there's no solid evidence that a human taking rapamycin for years will live a considerably longer lifespan. In fact, even with calorie restriction, as I said earlier, works well in most animal species, but when they did studies in monkeys, it didn't work as well. And when they do certain species of rats, when they do put them on a calorie restricted diet, not only do they not live longer, they live shorter lifespans. And scientists, a couple of scientists who study longevity, have suggested that even if a human being did follow, which is very hard to do, by the way, follow a calorie restricted diet, which involves, again, an average of 30 to 35% less daily calorie intake. Very hard for most people, cannot do it. I mean, it's very little food. For a man, that would be something like maybe 1,100 calories a day. It's very, very hard to do. But even if you did it, they estimate that would only give you probably about 7 years of added life. Now, if you are a cigarette smoker and you stop smoking, you are estimated to gain an extra 7 years of life. If you lose a lot of body fat and go on a diet and lose body fat, you will live an extra 7 years at least. So there's other ways to gain 7 years without starving yourself. That's the point. Now you might be saying at this time, well, let me see now. You said that mTOR is very important for muscle building. It's kind of an anabolic effect in muscle. So what would happen if you took this drug? Let's say you're interested in extending your longevity, and you listen to all these YouTube videos where you have all these people rah-rahing about how great rapamycin, it's going to make you live 40 years long, all this nonsense. And you say, well, I'm going to try rapamycin. First of all, it's not that easy to get. It's not a commonly prescribed drug. The only use for it in medicine, as I say, is to prevent organ rejects, especially kidney transplants. That's all it's used for in medicine. It has no other purpose. Most doctors will never, ever prescribe rapamycin because it's only used for that one purpose. So first of all, you'd have a little bit difficulty getting it, right? Now, the second thing to consider is, remember, the mTOR is needed for gaining muscle. So if you took rapamycin, theoretically, you'd be blocking any gains in muscle. You could take all the protein you want. You could train for 9 hours a day, and if you block mTOR, nothing's going to happen. You ain't going to gain any muscle at all. Now somebody might pipe in here. One of the rapamycin advocates will say, well, Jerry, we're not telling people to take rapamycin like the kidney transplant people do. We're telling them to take just small dosages of rapamycin, something like maybe 3 or 6 milligrams, maybe 2 times a week. If you take that small dose, you should get most of the longevity benefits of rapamycin without the negative effects on muscle. But that assumes that rapamycin, first of all, that's an assumption. Some people, not everyone reacts the same way to drugs. Some people have much more, let's say, potent reactions to drugs than others. It's very difficult to predict how a person will react to even intermittent small doses of rapamycin. And some people, it might not affect their muscle gains at all, taking the, let's say, 3 or 6 milligrams twice a week. And other people, it might actually blunt their muscle gains. And I think this would be especially true for people that are under 40. Why anyone under 40 would even consider taking rapamycin makes no sense at all. You don't need it when you're under 40. It's stupid. But, if you did, you probably would really, if you're involved in resistance training, it would probably significantly blunt your muscle gains. But let's assume you're over 40. You're taking these 3 to 6 milligrams of rapamycin a week to slow down mTOR and hopefully prevent all these age-related diseases. In fact, the worst thing about aging, by the way, is that the biggest risk for disease, degenerative disease, is aging itself. So if you could slow down aging for a substance like rapamycin, you would live longer because you would avoid most of the degenerative diseases like Alzheimer's disease, cardiovascular disease, cancer that shorten the lifespan. Now, let's say that you decided to take rapamycin. Remember, rapamycin is a drug, and there's a saying in pharmacology, only the dose determines the poison. Well, that applies to steroids. In other words, the more steroids and anabolic drugs you take, the greater the chance of risk factors. However, with rapamycin, you're taking minimal dosages of only 3 to 6 milligrams twice a week. But remember, every drug has side effects. If a drug didn't have side effects, it wouldn't work. It wouldn't work, period. It's that simple. Now, one of the reasons why, before I talk about what can happen with rapamycin, I want to mention that one of the reasons why mTOR, this is kind of important, why it promotes aging, besides promoting all those diseases I mentioned, is that mTOR blocks the process called autophagy. Autophagy, again, involves a kind of internal house cleaning of the body, where your body gets rid of old cells and kind of helps the body rebuild tissues, regenerates the immune system. This is very important for longevity. And anything that blocks longevity is going to interfere with life extension or health span. And unfortunately, mTOR immediately blocks autophagy. And that's probably the main reason why it causes all the problems related to increased aging effects and disease. Now, let's talk about basically what stimulates mTOR. As I said, exercise, including both aerobic exercise and resistance training, always stimulates mTOR. Protein intake, especially the branched chain amino acid leucine, stimulates mTOR. Testosterone, all the anabolic hormones, growth hormone, testosterone, insulin, IGF-1, all stimulate mTOR. The mineral zinc stimulates mTOR. Carbohydrates will stimulate mTOR indirectly because carbohydrates stimulate the greatest release of insulin, and insulin stimulates mTOR. Now, and an interesting thing related to food is that they've shown that whole eggs will stimulate mTOR, whole eggs, but egg whites don't stimulate mTOR. Now that's interesting that nobody ever talks about that, but that has interesting implications when you think about it, because like I say, mTOR is very important for muscle building, and they've shown in some studies that where they've given one group whole eggs, another group only egg whites. The group that took the whole eggs, and some of them were young bodybuilders, made better gains with resistance training than the people who consumed only the egg whites. Now, maybe the reason for this, I thought it was because the whole eggs have almost all the nutrients found in eggs are found in whole eggs, in the egg yolks. And that's what I thought the reason was, and also because whole eggs simply have more protein. When they talk about eggs being a great protein, they're talking about whole eggs, not egg whites, because half the protein in an egg is found in the yolk, half is in the white. But it could be that one of the reasons why whole eggs is more anabolic than egg whites is because whole eggs stimulates mTOR and egg whites don't. Never thought about that, but think about it. Now the thing about getting back to, I know I'm going back and forth, but I want to make sure I get all this in, because a lot of times I do these videos and I slap my head afterwards. Oh man, I should have talked about this. So I'm going back. I want to get all this information in because I think it's very important. As I said, the biggest problem with mTOR from a health standpoint is that it blocks autophagy. Now, there is a great natural antidote to that. There's another substance called Ampk. Ampk is produced in the muscle. For example, when your muscles get low in energy, when you are depleting glycogen, Ampk begins to become, it's an energy sensor in muscles. So it can sense when the energy stores in muscles and cells are low, and that's when Ampk goes to work. And among other things, it does a couple of things. It stimulates increased use of fat as a fuel source. In other words, Ampk is a fat burner, or fat. It stimulates fat oxidation, to be more exact. But more importantly, from a health aspect, Ampk is the yin to mTOR's yang. In other words, Ampk does the opposite of what mTOR does. Ampk will actually inhibit muscle protein synthesis, but it also stimulates autophagy. So the ideal situation, as you get past 40, you don't want to eliminate mTOR completely. In other words, you wouldn't want to take, let's say, rapamycin every day to knock out mTOR, because then you would get a situation where you get something called sarcopenia, which is an age-related loss of muscle that's highly related to increased mortality. What you want to do is control mTOR, and the best way to control it is by stimulating mTOR at certain points. For example, in proximity to your workouts, when you take in your protein, that will stimulate mTOR, and you get the muscle protein synthesis effect. So you want to stimulate mTOR when you most need it, such as after workouts when you're trying to increase muscle protein synthesis to increase muscle gains. At other times, you want to blunt, especially, I'm talking if you're over 40, by the way. This doesn't apply if you're younger. At other times, you want to blunt mTOR and stimulate Ampk, which will help control mTOR. Now, how do you, first of all, how do you raise Ampk? How do you lower mTOR? In other words, how do you control mTOR? What are the things that you can use to naturally? Well, the first one, of course, is rapamycin. Now, the problem with rapamycin, as I said, it's a drug. It's hard to get. Most doctors will not prescribe it. Honestly, I don't even know where these people are getting rapamycin, because I know there's quite a few people, according to their YouTube videos, they're already taking rapamycin in the low dose technique that I mentioned, 3 to 6 milligrams twice or 3 times a week. I have no idea where they're getting it, because you go to the average doctor, you ask him for rapamycin, he won't even know what you're talking about. And even if he does, he's going to say, why would you want an immunosuppressant drug that knocks out your immune system? Could you imagine taking rapamycin when they had at the height of the pandemic? You know, when everybody was, everyone was catching COVID-19. You imagine taking a drug that would suppress your immune system at that time? They've shown in studies that the people that got the worst cases, or people who died from COVID-19, they had one thing in common. They had a poor immune response. So you're going to take a healthy person, give them a drug which knocks out the immune system when COVID's still going around? No. See, that's the reason I myself would not take rapamycin. First of all, I don't think there's enough evidence as yet that it'll really show definite life extension benefits. I don't like the fact that it cuts out mTOR. I mean, I need it to retain as much protein as I can, as much muscle as I can at my age. But I don't like the fact that it's an immunosuppressant. I was going to try and enroll my dog, Bruno, who was over 20 years old at the time. I was going to try and enroll him in that dog study of rapamycin. But then I thought about it, and I said to myself, the biggest cause of death in dogs is cancer. In humans, it's cardiovascular disease. In it reverses. In dogs, it's cancer first, then cardiovascular disease. And I said to myself, cancer is a lot of it has to do with a poor immune response. I said, and I was afraid that my dog was already 20. If I put him on rapamycin, I was afraid it might, if he has any type of tumor that in his body, it would stimulate it, and I didn't want to take the chance, so I didn't do it. And I don't take rapamycin. Again, I'm not impressed with the evidence yet. And also, you consider the side effects of rapamycin. I'm just going to read it off, some of the side effects of rapamycin. And this is at any dose, by the way. This can happen even with the low doses. Decreased potassium, anemia, lower blood platelets, those are the clotting factors in blood, increased blood pressure, decreased kidney function, increased blood triglycerides, which is a cardiac risk factor, increased joint and muscle pain, nausea, headache, abdominal pain. These are insulin resistance, and of course, decreased immune function. These are all possible side effects of rapamycin. And again, to be fair, the people that are taking the low dose say that they don't experience any of those side effects because of the fact that they're taking intermittent low doses. Again, 3 to 6 milligrams, 2 to 3 times a week. But again, I hate to sound redundant, you never know how you're going to react to a drug. You never know. Some people might even take those low doses and still get these side effects. You don't know until you do it. And I'm not willing to take the chance until actually, they have other drugs that are, I think they're already out. They're called Rapalogs. And they work very similar to rapamycin in that they inhibit mTOR, but supposedly these newer drugs have far fewer side effects. They're much safer. If I were to take any type of mTOR inhibitor, I would go with the Rapalogs. Rather, I would not take rapamycin. Why would you take a drug where they have newer and better versions? It doesn't make any sense. But I guess some of these newer drugs are still in an experimental stage, so they're a little bit harder to get than rapamycin. But let's say that you want to oppose the effects of mTOR by raising Ampk, which will effectively neutralize the negative effects of mTOR. What can you do? The drug Metformin. The drug Metformin is normally used to treat insulin resistance or prediabetes, and they give it to regular people with type 2 diabetes, also to help control blood glucose, because it seems to prevent the excessive release of glucose from the liver. But Metformin also, one of the mechanisms of mTOR is that it increases Ampk. So if you wanted to go to the drug route, you could go with Metformin. Some people can't take Metformin because it says they say it gives them gastrointestinal distress. They get nauseous, whatever. I'll be honest with you. Here's a full disclosure here. I don't normally like to talk about my personal drug regimes, but I've been taking Metformin for 20 years because I have a heavy strain of diabetes in my family. And I originally took Metformin 20 years ago because there were some studies at the time showing that Metformin, because of the Ampk effect, stimulated fat loss. So I originally took it as a fat loss promoter, but then as I got older and my blood glucose started to get a little bit out of hand, it started going up, I stuck to the mTOR. So I've been taking it for many years. The number of side effects I've had from mTOR is 0. I've never had any gastrointestinal effects. I don't take a lot of Metformin. I take 500 milligrams twice a day. Supposedly, they say that the big problem with Metformin, because of the Ampk effect, remember I said Ampk opposes mTOR, so some studies have showed that ingesting Metformin can interfere with gains that are possible through exercise, including muscle gains, again, because of the inhibition of mTOR. But the endurance gains are more effective because one of the mechanisms in Metformin is it blocks a certain mechanism in the mitochondria that are involved with energy production. That's why it increases Ampk. But whether Metformin has blunted, I could tell you that in the early years of using Metformin, it didn't affect my gains whatsoever. I made regular muscle and strength gains, didn't take any other drugs, no steroids. So Metformin did not affect me at all as far as muscle gains. Right now at my age, it'd be difficult to say whether Metformin is interfering with my muscle gains, but I'm not going to stop taking it because it produces a number of health effects, including an increase of Ampk. Now, if you want to go the natural route, let's say you don't want to take this drug, Metformin, which does require a prescription. If you want to go the natural, there's a couple of supplements that actually also increase AMPK. The foremost among them is a herb called berberine. Berberine works very similar to metformin. Some people call it the natural form of metformin because it also stimulates AMPK. Curcumin also stimulates AMPK. Resveratrol stimulates AMPK. Caffeine, just drinking coffee, will stimulate AMPK. Will coffee interfere with muscle gains because of that? Nah, it's a weak effect, but it does stimulate AMPK, and in that way it'll actually help you, oxidize more fat. Intermittent fasting lowers mTOR and stimulates autophagy. That's the good news. The bad news is that the usual style of intermittent fasting, which is like 12 to 16 hours, very little autophagy, a little bit of mTOR inhibition, not much. The only reason you're getting mTOR inhibition with a short-term intermittent fasting is because of you're not eating any food, you're not eating any protein. But to really get a significant amount of autophagy, you'd have to fast for at least 2 days, 24 to 48 hours actually. That's when you get a significant amount of autophagy from fasting. Ketogenic diets that eliminate carbohydrates, have maybe 25 grams a day or less, that stimulates AMPK. So, as I said, quercetin is another nutrient. Eating blueberries stimulates AMPK. What else? Let me see. EGCG from green tea, main antioxidant green tea, that stimulates AMPK. Genistein in soybeans stimulates AMPK. So all of these substances will stimulate AMPK. So what's the point? Let me sum up by saying that mTOR is very important for muscle growth. Again, it directs amino acids down an anabolic pathway that results in increased muscle protein synthesis. However, unfortunately, as people age, mTOR tends to get out of proportion with AMPK, and excessive mTOR is associated with most degenerative diseases linked to aging, including Alzheimer's, cardiovascular disease, joint problems, cancer. All of these things are related to increased mTOR, because remember, mTOR stimulates cell growth. You don't want excessive cell growth when you're older, because cancer is a process of uncontrolled cell growth. The way to control mTOR is to raise your AMPK level. And by the way, doing aerobic exercise alone, just as resistance training raises mTOR, aerobic exercise will raise AMPK. So even if you include an aerobic exercise component in your training, you'll get an AMPK elevation, which is good. So again, the thing to remember is as you get older, you want to do a kind of you want to stimulate mTOR at the right time. In other words, taking your protein amino acids in proximity to your workouts. Later on, you can still eat protein, but you want to go easy on it. Don't go crazy. Don't eat massive amounts of protein. I mean, there's been other studies about that. It's a slippery slope, because if people over, let's say 50, if they cut their protein down too much, they will definitely lower mTOR, but they'll also stimulate, push themselves into sarcopenia, which is a loss of muscle. So it kind of canceled out the whole benefit of lowering mTOR. So you got to be careful. But you don't want to go crazy eating tons of protein, taking tons of leucine and other amino acids when you're over 40, because that'll stimulate excessive mTOR, and in most cases you're already producing too much mTOR. So I'll just end it here. And I'd be careful. I just want to add one other thing. One of the things that gave me the idea for this video is I've viewed quite a few. There's literally dozens of YouTube videos of these people advocating rapamycin and calling it the fountain of youth. They're saying it's the only drug that's going to extend human lifespan. That may or may not be true. But to make a definitive statement that taking rapamycin in any dose will make you live substantially longer is simply not proven as yet. There's no proof whatsoever in humans. In some animals, possibly. In humans, none. So, and remember, rapamycin is an immunosuppressant drug. If you take rapamycin, even at the low dosages, two or three times a week, and you're exposed to, let's say, a virus or a bacteria, the odds are you will get sick because you've lowered your immune response. So I'll end it at that. If you want more information about nutrition, exercise science, anti-aging research, ergogenic aids, hormone therapy, supplement science, which supplements work, which ones don't, women's health and fitness, and many other topics. I cover more topics in my Applied Metabolics than any other digital publication on the internet. No other publication on the internet also comes with my over 60 years of experience, both in the gym and in personal study. Nobody can match that. And it's all included in Applied Metabolics. It's 30 to 45 pages every month. There's no advertisements, just pure evidence-based and empirical information based on my many years of experience. So subscribe today at www.appliedmetabolics.com. You will learn far more from reading Applied Metabolics than you'll get from any of these videos, including the 6-hour podcasts that are mostly a lot of hot air. I could never. You couldn't pay me any amount of money if you said to me, "Hey, I'm giving you Elon Musk's entire fortune to sit through 8 hours of pod." I'd say, "I'm sorry, it's not going to work," because I'd fall asleep after about an hour. So I'd lose the money anyway. So, but my point is, there's far more information, and it's written in plain English. I've been a writer for almost half a century. I know how to write for the public. I wrote for major bodybuilding magazines for years. I have thousands of published articles. It's easy. Applied Metabolics is easily understood by anyone who got as far as the 6th grade. It's not hard to read at all. So, and I guarantee you, no matter what your level of, let's say, knowledge or education, when you read Applied Metabolics, you will learn something. I guarantee it. And Applied Metabolics, simply put, is the antidote to all the nonsense and garbage that's promulgated on the internet in videos and blogs. A lot of it's just crap. Because, and I said this before, I'll say it again, anyone can post a blog or post a video, and then you have a lot of these guys that have the advanced degrees, the PhDs, the MDs. I mean, they're not only is their information not always correct, and I'm not saying they're always wrong. Don't get me wrong. So a lot of this stuff is knowledgeable, but the point is, just because you have an advanced degree doesn't make you a know-it-all, where you're absolutely irrefutably correct on everything you say. I've caught them in dozens of errors, some of these people, and a lot of them are selling products. Nothing wrong with that. I mean, there's nothing wrong with trying to make a living or make a little extra money. But, their main reason for posting these videos eventually becomes to sell one product or another. There's one guy who's gotten very popular, who I don't even want to mention. He's a doctor, supposedly. He sells a vitamin, which astounded me when I looked at the formula. It doesn't even have the minimal daily requirements of most vitamins and minerals, because he says that taking too many vitamins and minerals are dangerous. And he's selling this supplement, which probably cost about 30 cents to make. He's selling it for $50 a bottle. This is an example of what you have to be careful of with some of these other videos. So just a little warning about that. But anyway, subscribe to Applied Metabolics. Again, www.appliedmetabolics.com. When you subscribe, send me an email, and I'll send you an invitation to join the private Applied Metabolic Facebook page, where each day I post new information on nutrition, exercise science, and general health. This stuff is like literally, I hate to use a cliche, it's hot off the press, the stuff I put in on my Facebook, my Applied Metabolics Facebook page. Which, by the way, since I'm on a little tangent here, I hate certain buzzwords that you hear a lot in these videos, like, let's take a deep dive into looking at blah, blah. What is this deep dive crap? I mean, I hear it over and over again. It's like chalk across a blackboard. It's like the word. It's like the way they use. What is that word they use for to describe a natural bodybuilder? A natty, natty. In other words, they won't say natural bodybuilder. They say he's natty. What the hell is natty? Why do you have to say natty? Because most people who aren't into, but they won't know what natty means. They'll think the guy has some sort of disease. Why not just say natural? It's so hard to say natural instead of natty. Natty, when you say natty, you sound ignorant and stupid. I have to tell you. Anyway, that's just my rant. You'll pardon my rant. Anyway, if you want to have the best friend you'll ever have, go to your local shelter, adopt a dog. So, thanks. This is a really long video, but you know, it was an important topic. I think people need to know about this stuff because controlling mTOR really could make a huge difference in your health and longevity past the age of 40. And with all the emphasis on protein, people need to be aware of the effects of mTOR. Thank you for listening.